Controlled Dynamic Process Project by Kevin Cuevas and Grant Webster. So what is our dynamic system? Our dynamic system is a mechanism that turns the angle on the gas pedal into revolutions per minute as displayed on the dashboard dial. For simplicity purposes, our system will consist of the mechanism that turns the angle of the pedal to the revs per minute of the crankshaft, and also the mechanism that measures the crankshaft's revs per minute and displays it on the dial. The main feature in our simplified system is the spring constant of the pedal. The spring constant restores the pedal to its original position after you press on it. The system is continuous, as there's an infinite amount of angles that both theta of the pedal and the RPM could be. The input of the system would be theta of the pedal in degrees. As shown in the picture, theta is defined as the angle between the y-axis and the actual pedal. The output of the system is RPM of the crankshaft as displayed on the dial. The units for this are kilorevolutions per minute. The measure variables are theta of the pedal and RPM. The feedback used by the system is the difference between the actual RPM and the RPM desired. Different RPMs will be desired depending on your driving needs. Say for example that you're driving at 2K RPM. Now you're entering the freeway and want to speed up. So you want to catch up with the flow of the traffic. Once you reach a relatively high RPM, you have to switch gears and repeat the process. So here's how our control looks like. The input is the angle of the pedal, the output is RPM, the plant is a gas pedal to RPM mechanism, and our control all depends on KD, KI, and KP values. The rise time is a performance metric being used in our simple system. As mentioned before, you ideally want to shift gears as smoothly as you can. There are two coordinate frames involved in our system. The frame defined to measure theta of the pedal, as well as the frame used to measure the RPM of the crankshaft. The z-axis of the pedal frame points outward from the driver's side. The y-axis points to the ground, and the x points to the back of the car. The z-axis of the crankshaft frame points out through the front of the car, and the x and y-axis could be chosen arbitrarily. Notice that the RPM is not concerned with the frame, but rather the magnitude of omega dot of the crankshaft.